to look at a dihybrid cross. This is the same thing as a monohybrid cross, except for we have two different traits we're looking at. So I've got a couple of examples. This first one is that guinea pig example that we looked at on the worksheet. We can see here that it already gives us the parent phenotype, so that's already given for us. So if we fill in the Punnett square or the dihybrid cross, we do it the same way that we would the monohybrid cross. We'd bring down and over. So you do each letter at a time. So for this one, it would be capital B, capital B, capital L, capital L. So then if we fill all of those in, we got capital B, capital B, capital L, lowercase l. Again, the capital is always going to go first. That's just a formality. But it won't change whether or not it's dominant or recessive, but that's just the way that we write it, is the capital letter first. Once these are all filled in, you can go and look at the bottom part. We need to figure out the phenotypic ratios. So how many out of 16? So how many are have black and short fur? How many have black and long fur? How many have white and short fur? And how many have white and long fur? And here it gives us our genotype. So if it's homozygous dominant, it will be black fur. If it's homozygous recessive, it will be white fur. And then same for short and long hair. So if we go through and we count all of the ones that are black with short fur, anything that's got that dominant allele for the B and that dominant allele for the L, we count that. So even this one right here, we've got capital B, lowercase b, capital L, lowercase l. We still count that as being black with short fur because that dominant allele is present. So remember our law of dominance, Mendel's law of dominance, or the principle of dominance, states that as long as that dominant allele is present, that's what's going to be expressed. So we have 9 out of 16 are black with short fur. So now we need to calculate black with long fur. So that's going to be either homozygous dominant or heterozygous for the fur, and then it's going to be homozygous recessive for the hair length. So we've got 3 out of 16 of those. So we've got homozygous dominant and homozygous recessive here, heterozygous and then homozygous recessive, and then heterozygous and another homozygous recessive. Then we need to calculate white with short fur. We're going to have 3 out of 16. Again, we've got our white's going to be homozygous recessive, and our short fur is going to be homozygous dominant or heterozygous for that short hair genotype. So in this example, we have 3 out of 16. And then finally, white with long fur is both going to be, are both going to be homozygous recessive for hair color and for hair length. And we've only got 1 of those, so 1 out of 16. So here's another example. This is what would you do if it does not give you what the genotypes are for the parents. So we don't know what the genotype is. We don't know how to segregate all the gametes. So how you do that, let's look at our parent allele. So for, let's say that this is dad. He's got, he is heterozygous for hair color and hair length. So the first thing you do, let's pull that down here. We've got our genotype right here. We start with the first letter of the genotype. So we have our capital B here. So we're going to pair our capital B with the first letter of the second set of genotypes. So capital B is going to be paired with capital L. And then capital B is going to be paired with the second letter, so then it will be capital B lowercase l. So then we do the same thing for the other 2 alleles. So we've got lowercase b is paired with capital L, and lowercase b is going to be then paired with lowercase l. So here's our genotypes. That's what I just pulled from here. And these right here are going to go up here in these blanks. So then let's do the same thing for mom's genotype. So we've got homozygous recessive for hair color, and then heterozygous for hair length. So we're going to do the same thing. We're going to pair our first letter with our first letter, and then the first letter with the second letter. So we get lowercase b, capital L, lowercase b, capital L. Then we do the same thing with the second letter. So we're going to pair the second letter with the first letter, and the second letter with the second letter. And that gives us lowercase b, capital L, lowercase b, capital L. and that goes in those blanks. So then we can go back to our dihybrid cross here, and these gametes are going to go on the side. So the male's gametes are going to go on the side, and the female's gametes are going to go on the top. So when we move those over, that's what we get. It's the same thing that we have here. It's just moved down. So then when we fill in our dihybrid cross, we do it the same way that we did the previous example. We'll come down and then over. So this one is actually wrong. This should be capital B, lowercase b, capital L, capital L. There we go. Now it's right. And then, of course, once we get down here, you can see that it'll be capital B, capital B, capital L, capital L. So then we need to find our phenotype. So how many are the offsprings, or how many offsprings are there? So we've got 4 out of 16 are going to be that black with short fur. So we have our homozygous dominant or our heterozygous for hair color. And then we have our heterozygous or homozygous dominant for our hair length. Then we need to count up how many are black with long fur. So we've still got our dominant allele here and our recessive allele here. There are 0 of those. Same thing for the white and short. So we need to find our homozygous recessive for fur color and our heterozygous or homozygous dominant for hair length. And we have 8 of those. And then we have none left. So that means we have 0 that are white with long fur. So that's how you do a dihybrid cross. Hope that helps a little bit. Again, leave any private comments if you're confused, and I will help you as best as I can.